Once ICES research was removed from NASA and it was maintained outside of academia and outside of big business, the development was able to accelerate markedly. Using private funding and our own resources, we were able to start doing significant studies outside of the universities, outside of NASA, and the results accelerated markedly. On this slide, we show a summary of the first major veterinary study performed at Texas A&M Veterinary School. This used Generation 2 PEMF technology, which was an advanced version of the technology I had developed for NASA some years earlier. It was a double-blind, controlled clinical study. It was private research, it was not published, and it involved using a critical bone defect in the rabbit ulna. You can see this defect. It's a piece of missing bone that you can see in the far left radiograph, which is an X-ray. That gap should never heal. When we applied ICES to that bone gap, the question was, does ICES allow the bone gap to heal when it otherwise would not, or does it have no effect at all? In the two narrow images slightly to the right, you see the answer to that question. When you do not apply ICES, you get no healing of the bone gap. That's what's shown inside the red circle. When you apply ICES to the wound area, within 4 weeks you start to see very significant bone regrowth in the bone gap. The results of this study yielded a lot of information that we maintained privately for the development of ICES technology. In particular, it told us a lot of things about exactly what the waveform needed to be and exactly what the magnetic fields needed to be like in order to get the maximum biologic response. This slide shows a summary of all of the data from the Texas A&M rabbit ulna defect study. These are 3D CT images, where CT stands for computer tomography. It's a computer-generated 3D image of the bone to show how well it's healing in the gap. The top row of 5 images shows data when we used a PEMF value that was well above what we thought was the minimum threshold for effectiveness. In 3 cases, you see partial healing, which you would never have expected to see if no intervention was made. In 2 of the cases, you actually see essentially full healing of the bone. These were assessed independently by veterinarians who have expertise in this area. When PEMF was used just at what we thought would be the effective biological threshold, you see the results in the second row. We had 1 bone that didn't heal at all inside the red circle, and then 2 bones with significant partial healing. And this is after just 4 weeks. We really shouldn't have seen any healing in any of these. The bottom row of 10 images shows the results for our controls in this study. A controlled scientific study has to include a group where you don't really expect to see any changes. In this particular case, we did see 1 case of suspected partial healing as shown inside the yellow circle. In all the other cases, there was no significant evidence of healing whatsoever. That's precisely what we would have expected for a negative control. So these data show very clearly that even for a very short period of time, second-generation PEMF systems can accelerate bone healing and in fact allow bones to heal over a significant wound where they would otherwise never heal.